Welcome back to another video. I hope you're having a great day. In this video, we're going to talk about set operations involving cardinality. So let's recall what cardinality is. Cardinality is the number of elements in each set. Okay, so we're going to have Venn diagrams and we're going to have information that instead of it giving us the elements that are in each set, it gives us the number of elements in each set. So we're just going to work some examples. We'll also work a survey example, which is an actual application of where set theory is used or how set theory is used. But in this example, it gives us this Venn diagram that has two sets, A and B, and then it has these numbers in the different regions. And by the way, I put these Roman numbers on here because sometimes you will have the different parts of the Venn diagram separated or labeled by Roman numerals. So this is part 1, which is just this part. Part 2, which is this middle part. Part 3, that part, and part 4 is the outer part. So the textbook that we use in my class actually separates it out like that, and I just wanted to make sure you knew that the Roman numerals breaks it up into different parts. So don't let the Roman numerals confuse you. But the thing that's different in this Venn diagram is that these numbers are not elements. So before we were looking at a Venn diagram, and if we saw 17 in the circle, that meant that this set A had the number 17 in it, and it also had the number 9 in it. Well, this time, since these operations involve cardinality, 17 is not an element in the set. 17 is the number of elements in the set. So what this is saying is that in this portion of the Venn diagram, in the things that are in set A but not in set B, there's 17 of them. There's 9 elements in this portion. There's 11 elements in this portion. And there are 7 elements out in this outer portion of the Venn diagram. So these numbers don't represent elements in the set. They actually represent the number of elements in the set. So that's the difference between what we did in previous videos versus what we're doing now. So we have this Venn diagram and we want to find some things. So there's various parts to this. The first part is determine the number of elements that are in set B. Okay, so set B is this circle right here. All right, this is set B. So all of these elements are in B and all of these elements are in B. So the number of elements in B will be the 9 plus the 11. There are 9 elements in B and there are also 11 elements in B. So there are 20 elements in B. For part B, or the second part, we want to find the number of elements that belong to A but not B. Okay, so we want to know the number of elements in A and not B. I'm just going to write it out. So I'm writing it out is A and not B. And remember and, so you can write and, or you remember and is the same as intersection. So A intersect not B. So that's the elements that are in A. So A is all of this circle. But this part also includes B. So since I don't want B, I take that out and I'm left with just this number right here, the 17. So that's the number of elements that are in A but not B. So for the third part, part C, we want to find the number of elements that belong to B but not A. So we'll write that as the number of B intersect not A, or A complement. Okay, so that means how many things are in part B but not in A. So if I include this, that includes A. So that means I only want this number right here, which is 11. So there are 11 things that are in B but not in A. For part D, we want to find the number of elements that are in A and B. So we will write that as the number of A intersect B. Again, the and means intersect or means union. Okay, so the number of A intersect B is this middle part, and so that number would be 9. And then for the last part, we want to find how many elements are in the universal set. So we will say N of U, which is our universal set, which is supposed to be up here. That means everything in this Venn diagram. So the 17, the 9, the 11, and the 7. You will add all of those up to figure out how many are in the universal set. So 17 and 9, well 9 and 11 is 20, that's 37 plus 7, that is 44. So there are 44 elements in the universal set, okay? So that's how you will perform these set operations involving cardinality with 2 sets. We'll look at 3 sets in a moment, but first let's do another example of a problem of set operations with two sets. For example 2, we have this Venn diagram, and this is A, this is B, and this is the universal set. Forgot to label those. And the only piece of information it gives us is that 7 is in this middle region right here. And also these regions are labeled with Roman numerals again, and it's specifically labeled that way in this problem because part of the problem is that we have to find how many are in each region. All right, so we have region 1, 2, 3, and 4. Now it also tells us that if n of A equal 23, that means the number of elements in A is 23. N of B equal 27. Again, that's cardinality. So the cardinality of B is 27. And N of U is 53. That's the number in the universal set. Then it wants us to find the number of elements in each region. Okay. Whenever you are trying to figure out how many number of elements is in a region, you always want to start from the innermost region and work your way out. So start in the middle and then work your way out. Well, in this case, we already know that the middle is 7. Okay, so then the next piece of information they give us is that the number in A is 23. So that means this whole circle right here should have 23 elements in it. Well, it already has 7 elements in it. So that means in order to figure out what goes in this first region, I would have to do 23 minus 7. And that would give me how many elements is in this first region, and you end up getting 16. And the reason it's 16 is because however many elements are in this circle A has to equal 23. Well, there are already 7 right here, and 7 plus 16 is 23. So that makes the number of elements of A correct. That's 23. All right, for the second region, we have that the number in B is 27, and we already have 7 here. That means the number in this region right here is going to be 27 minus 7, which is equal to 20. So there are 20 elements in this second region right here, and that is because the total number in B is 27, and I need for those two regions, region 2 and region 3, to add up to 27. The last part of this is that the universal set has 53 elements. That means all of the elements in 1, 2, 3, and 4 need to add up to 53. Well, in order to get to 53, I need to figure out how many elements are in sections 1, 2, and 3. Well, there's 16 plus 7 plus 20. So if you add all those together, if I write them on top of each other where I can add them easily, I get 43. So there are 43 elements across A and B, and it should add up to 53. So in order to figure out what's in this outside region, I would do 53 minus 43, which is 10. So that lets me know there are 10 elements in this outside region, and that's because all of these numbers in this Venn diagram should add up to 53 because that's the number of elements in the Venn diagram. So that's how you will find the missing regions. Start with the innermost section, which is already given in this case, and then work your way out. So figure out how many goes here, how many goes here, and then how many goes on the outside region. Okay, so these are examples of doing set operations that involve cardinality with 2 sets. Now let's look at 3 sets. Okay, so now example 3, this is an example of looking at set operations with cardinality. So I have 3 sets here, A, B, and C, and these numbers in each of these parts or portions represent the number of elements in those regions. Okay, so I have this set A that has 5, 1, 2, and 7, B has 6, 1, 7, and 3, and C has 2, 7, 3, and 10, and then this outer region has 8. Okay, so the first thing I want to do is I want to find the number of elements in set A. Okay, so I want to know what is the number in A. Well, A, it contains all of this right here. This whole circle is A. So that's the 5, the 1, the 2, and the 7. So A has 5 plus 1 plus 2 plus 7. That's 5 and 1 is 6. 6 and 2 is 8. 8 and 7 is 15. So for part A, the number in A is 15. Okay, there are 15 elements in A. The next thing we want to do is we want to find the number of elements that are in set B but not in set A. So we want to know what is the number of B intersect not A. That means how many things are in B but not in A. So this is B, this whole circle is B, but we don't want to include the things that are also in A. So take those out, and we're here with just the 6 and the 3. So 6 plus 3, which is equal to 9. So the number of elements that are in B but not A would be 9. All right, for part C, we want to find the number of elements that are in A or B. So that would be union A union B, A or B. So that would mean all of the things that are in A and all of the things that are in B. So all the things that are in this circle and all the things that are in this circle. So that would be the 5, the 1, the 2, the 7, the 3, and the 6. So 5 plus 1 plus 2 plus 7 plus 3 plus 6. So add all of those up. 5 and 1 is 6, 6 and 2 is 8, 8 and 7 is 15, 15 and 3 is 18, 18 and 6 is 24. So there are 24 elements in A union B. That means A or B has 24 elements altogether. For part D, we want to figure out how many elements are in set A and B. So in this case, this is the number of A intersect B. So A intersect B is the overlapping region of A and B, which is this region right here, which includes the 1 and the 7. 1 plus 7 is equal to 8. So there are 8 elements in A and B. Okay, we got 2 more parts to this problem. In part E, we want to find the number of elements that are in A and B, but A and C, but not B. A and C, but not B. So it would look like that. The intersection of A, C, and B complement. So I want it to be in A and C. So this is A and C, this region right here. But I don't want it to include B. So then it would be just the 2. So the number in A and B, but not C, would be this region right here, the region with the 2. All right, for the very, very last part, it says, considering the number of elements in set A, B, and C, how many of these elements belong to exactly 2 of the sets, okay? So let's talk about how many elements belong to each set. So when you start out here in this outer region, that means these elements belong to none of the sets. When you get to this region right here, that means these elements only belong to one set because they're only in the A. So these are the ones that belong to only one set, the 5, the 6, and the 10. So if it asks for how many belong to exactly one set, you will use those numbers and add them together. Now these numbers, the 1, the 2, and the 3, these numbers, those elements belong to exactly 2 sets. See, this one belongs to A and B, this one belongs to A and C, and these belong to B and C. So when it says how many belong to exactly 2 sets, then you will use those 3 numbers, 1 plus 2 plus 3, which is equal to 6. So how many belong to exactly 2 sets? It will be 6, okay? Now this number in the middle is how many belong to 3 sets. So there are 7 elements that belong to 3 sets. It doesn't ask you in this question, but I want to make sure you understand. That way, if you do get a question that asks you how many belong to 3 sets, you understand that that's those elements in that very, very center. All right. So this is an example with 3 sets. Now for this last example, we're going to look at an example of an application. So a real world scenario of how you can use set theory. And they're used a lot in what's called survey problems. So there are some survey problems on your homework that you will get the opportunity to work. And so this is a long problem. So I have my notebook here. So I'm going to read this to you guys. I'm also put it on the screen where you can see it. But it says a survey of 180 college men was taken to determine participation in various campus activities. 43 students were in fraternities, 52 participated in campus sports, and 35 participated in various campus tutorial programs. 13 students participated in fraternities and sports, 14 in sports and tutorials, and 12 in fraternities and tutorial programs. 5 students participated in all 3. I know there was a lot of information, so we're going to have to take this and break it down piece by piece. That's not even the question yet. That's just the setup. We're going to answer a series of questions about this, but the first thing we want to do is draw a Venn diagram and set this information up. And so that's why I have this blank Venn diagram up here. So I have 3 sets because there are 3 different things that were surveyed. The first one was that there were, first of all, the universal set. So N of U is the universal set, and this is example 4. There is 180 men that were surveyed altogether. So the number in the universal set will be 180, okay? The next thing is that there were 43 students who participated in fraternities. So I'm just going to call this first circle F for fraternities, and N of F is equal to 43. So I'm just trying to take all the information in this problem that is given. The next thing is that 52 participated in campus sports. So I'm just going to use an S to represent sports, and I'll just use that circle to represent sports. And so N of S is 52. And then the next thing is 35 participated in various campus tutorial programs. So I'm going to use T to represent tutorial programs, and N of T is equal to 35. Now, it also told us that there were 13 students who participated in fraternities and sports. So the number of F intersect S would be, what did I say, 13? That's the number of those that were in fraternities and sports. It also said that 14 participated in sports and tutorials. So that would be S intersect T, and that's equal to 14. It also told us that 12 participated in fraternities and tutorials. So fraternity intersect tutorials is equal to 12. And then the last piece of information that it gives us is that 5 students participated in all 3. And so that would be F intersect S intersect T. So the intersection of all 3 is 5. Alrighty. So now, before we even answer the questions, we want to just go ahead and fill in our Venn diagram to find the missing pieces. All right. And so remember, you want to start with the innermost part and then work your way out. All right. So the innermost part is the intersection of all 3. And that's what we have here. This F intersect S intersect T, which is equal to 5. So that means there were 5 that participated in sports, fraternities, and tutorials. All right, so then I'm just going to work my way up. So F and T is equal to 12. That means there were 12 that participated in fraternities and tutorials. So here's the region that represents fraternities and tutorials, and there should be 12 in that region. Well, there's already 5. So in order for me to figure out what that other piece should be, I will do 12 minus 5, which is 7. So that means this should have 7 in it, because this total should be 12. So 7 plus 5 is 12. So that makes that overlapping region have 12 elements. The next thing is that the number in sports and tutorials should be 14. Well, sports and tutorials is here. It should be 14. There's already a 5 in there. So to figure out what goes in this region, I will do 14 minus 5, which is equal to 9. So there should be 9 in that region right there. And then the number in fraternities and sports is 13. So fraternities and sports here, that's this region, should be 13. There's already a 5 in there. So I will do 13 minus 5 to determine this region right here, which is 8. Okay. So now as I'm working up, the next thing I know is that the number that were in tutorial programs was 35. So that means this circle should have 35. Well, this circle already has 7 plus 5 plus 9 in it, which is 21. 7 plus 5 is 12. 12 and 9 is 21. And it needs to have 35. So to figure out what goes in this open region, I will do 35 minus 21, which is equal to 14. So there is 14 in this region. Okay, we moving on up. So now we on the number of sports. There should be 52 in the circle for sports. There are 8, 5, and 9. So we're going to add 8 plus 5 plus 9, and that's 13 plus 9, which is 22. There should be 52 here, so I need to do 52 minus 22, and that gives me 30. That means there are 30 in this region. Okay, so hopefully y'all see what I'm doing. I start in the middle and I'm working my way out. I'm slowly working my way out, and I'm just going up the list of the information that I wrote down based on what was given in the problem. So the next thing I have is the number that we're in fraternities should be 43. Here's my circle for fraternities. It already has 8, 5, and 7 in it, so I'm going to add those 3 together. And that gives me 13 plus 7 is 20. And it should be 43 in there. So to figure out how many goes in that other region, oh, that's a 20. I do 43 minus 20, which is 23. So 23 should go in that region right there. Now the last region I have is the universal set. There should be 180 in the universal set. And so the universal set contains everything that's inside of here. So I'm going to erase this. I'm grab my eraser over here. I'm going to erase this so I can use this space to calculate what's in this outer region right here. So in order to determine what's in that outer region, I need to figure out how many elements are in these circles. So I have 23 plus 8 plus 5 plus 7, that's all of those, plus 9 and 30 plus 14. So I want to add all of those up. And when I add them up, I get 3 and 8 is 11, 11 and 5 is 16, 16 and 7 is 23, 23 and 9 is 32, and 4 is 36, 3 and 2 is 5, 8, 9. So I get 96. So there are 96 elements in these 3 circles. There should be 180 elements total. So to figure out what goes on this outside region, I need to do 180 minus 96. So 10 minus 6 is 4. 17 minus 9 is 8. So there should be 84 elements in this outside region. Okay, so we still haven't answered the questions that were given. The only thing we've done so far is just set up the Venn diagram, which will make answering the questions a whole lot easier now. Okay, so now let's look at the questions that are asked and let's work through those. Okay, so the first question is how many participated in only sports? Okay. So here's my sports circle, but if they're in these regions, they participated in something other than sports. So the number that participated in only sports is 30. So for part A, the answer is 30. That's this number right here. Those are the ones who participated in only sports. For part B, we want to know how many participated in fraternity and sports, but not tutorial. So B, we want to know, so let me change this. This is N of S. I'm going to just write this so you'll know. That's N of S. No, that's not N of S. Sorry, I'm going to just leave it as 30. So for part B, we want to know how many participated in fraternities and sports, but not tutorial. So I want to know how many were in F and S. So here's my F and S, fraternities and sports, but not tutorial. So I want to take out the tutorials piece. That leaves me with just this number right here, the 8. So part B, your answer would be 8. For part C, we want to know how many participated in fraternities or sports, but not tutorials. So or means instead of taking the overlapping region, I want to take all of the ones in fraternities, all the ones in sports, but the ones that are not in tutorials. So if I take out the tutorials, so all of my fraternities and sports are here, but if I take out the tutorials, then I'm left with just those 3 numbers, the 23, the 8, and the 30. So I need to add those together to get that there are 61 who participated in fraternities and sports, but not tutorials. Okay, so hopefully you get how I'm looking at these and figuring out these numbers. Okay, for part D, we want to figure out how many individuals participated in exactly one of these sports. So remember, the exactly one are the ones that are in these regions right here. So the 23 plus 30 plus 14. So that would be 67. So there are 67 of the men who participated in exactly one of the activities. Okay, for E, we want to figure out how many participated in at least 2 activities. So now at least 2 is different from saying exactly 2. If it asks for exactly 2, then we will want these numbers right here, the 8, the 7, and the 9. Because remember, those are the regions that represent 2 sets overlapping. But it said at least 2. So at least 2 means they participated in 2 or more. So we want the number that participated in 2 and also the number that participated in all 3. So now that would include all of these numbers right here. So these are the ones that participated in 2, and then these are the ones that participated in 3. So to get that answer, I need to add the 8, the 5, the 7, and the 9. That's 8 and 5 is 13, 13 and 7 is 20, 20 and 9 is 29. So there are 29 of the individuals who participated in at least 2 of the activities. And then the very, very last part is how many did not participate in any of the activities. And so that's really, really easy from our Venn diagram. That is this number out here because these are the ones that are not in any of those 3. So that answer would be 84. So the answer to that last part is 84. So the answer to F, I'll just squeeze it in here, is 84. All right. So that is how you break a survey problem down and work it out. You have to take it, break it down piece by piece, and then once you complete your Venn diagram, it makes your questions a little easier to answer. So go ahead and break that down and work it out. Now, if you have any questions about anything I said in this video, again, I'm going to continually tell you this. Don't hesitate to put them in the comments, or you can email me personally and I will respond. Thank you again for tuning in. And if you haven't already, make sure you hit that subscribe button, and I will see you all in the next video.